When you're done with this video, you guys, you should be able to go on Khan Academy and complete these 4 assignments without having to watch all the million videos that I assigned you, although they are there if you want to watch them. So first we're going to review congruence and transformations. Okay. Then we're going to see how we can determine congruent triangles given some theorems. Then we're going to learn how to find angles once we know triangles are congruent. And then you should be able to take the congruence unit test. Okay, these are the actual names of the assignments I've given you in Khan Academy, the practice problems. Okay, so just to refresh your memory of what we've learned earlier this year is congruent shapes are shapes that have the same size and shape. So they're the same in every possible way. And in geometry, we show that by using this symbol. It's an equal sign with a squiggle on top. Similar shapes, on the other hand, are shapes that have the same shape but a different size. So for example, you could have a small triangle and a big triangle, same shape, right? Same angles, but they're clearly a different size. And we indicate that with just the squiggle. So last year and earlier this year, we looked at both rigid transformations and dilations. Rigid transformations were things like translations, where we slide things around the coordinate grid, and reflections and rotations. When you perform a rigid transformation, that results in congruent shapes, always, okay? A dilation, on the other hand, is when you multiply all the vertices by a scale factor. If you multiply a shape by a scale factor that is not positive or negative 1, you are going to change the size of the shape. It maintains its shape, but the size is different. So that results in similar shapes. Okay. Now think if you multiply something by a scale factor of 1, you get the exact same shape. If you multiply something by a scale factor of negative 1, it just gets rotated 180 degrees, but it's still the same shape. That's why I said scale factor, not positive or negative 1. Okay, now let's talk about triangle congruence theorems. There are 5 of them. They are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So what the heck does that mean? All right, here we go. So we just talked about congruent shapes. Well, congruent triangles are triangles that have the exact same shape and the exact same size. So that's indicated here by this notation. This side is equal to that side. This side with 2 tick marks is equal to that side, congruent. This side with 3 is congruent to that side with 3. And then these angles with 1, with 2, with 3 are also congruent. But do you need to know all 6 of those pieces of information to determine if triangles are congruent or not? You actually don't. So that's what the theorems allow us to do. Have less information and know that they're congruent. So side, side, side is one of the theorems that we have that we know that if all 3 sides in 2 triangles are equal, then those triangles are congruent. So if we had A, B, C, and we had Q, R, S, we would be able to say that side AB is congruent to QR, so let me show you this because they have to be in the correct order. Side AB is congruent to QR, BC is congruent to RS, and AC is congruent to QS. And if that is the case, then we know all these angles are equal, and by the side, side, side theorem, these triangles are congruent. Side, angle, side. If we know that a side and another side, and the angle in between them has to be in between them, that's why it's in the middle. If we know those are congruent, then we know that the triangles are congruent. So we have A, B, C, it's call this one DEF just to be different. If we know that AB is equal to DE and AC is equal to DF, and we know that angle A is equal to angle D, we know that those triangles are congruent. So we have a side, an included angle, and another side. Side, included angle, and another side. They are congruent. Angle, side, angle. So this one says if you have two angles and the side in between them are equal, those triangles are congruent. So here we have angle A is congruent to angle D. Angle C and angle F are also congruent. And this side, AC, is congruent to DF, right? The included side. Then we know these triangles are congruent. Angle, angle, side. We have two angles next to each other, and then the side that is not in between them. Okay, so we have these two angles, and we have the side not in between them. If we have those, we also know these are congruent. We also know the angle measurement of this angle as well, right? Because we know that all the angles add up to 180. So these are congruent. All right, hypotenuse leg. Now this goes for right triangles. So if we know that they're both right triangles and we've got two sides that are equal to one another, or excuse me, we have a hypotenuse, the hypotenuse are equal and the legs are equal, well, we therefore know that this other side is also equal because of the Pythagorean theorem. So hypotenuse leg is just sort of a quick way to also know that side, side, side is also congruent. So hypotenuse leg, we also know that these triangles are congruent. So I often get asked, well, what about angle, angle, angle? If I know all three angles, well, this triangle has all of their angles that are equal, same shape, but are they the same size? No. So angle, angle, angle is not a congruence theorem. Okay. Side, side, side is, but not angle, angle, angle. All right, I often get asked about this one, ASS. Okay, I have a little picture of a donkey there. You can figure out why. If I have two sides and an angle that is not, right, that's just opposite those sides, these have the same sides, right? This angle is exactly the same, okay? This side is exactly the same, but this line here could be here, or I rotated it, right? This line is the exact same thing as this line. These angles maintained, but these angles now changed, and so did these. So ASS is not a triangle congruence theorem. No to the donkey. Okay, so this is a type of problem that you're going to be asked. I think this one is an example of find angles and congruent triangles. So let's look at this. First of all, do we know that these are congruent? Okay, well, we have a side here, 44.3, right? We know that this is congruent to this. We know this is congruent to this. Okay. We know this third side is the exact same side. So this line is in both triangles. So we have side, side, side congruence there. So if we know that, we then know that if triangle ABC is congruent to triangle D, and we know that the 4.3 is opposite B, the 4.3 is opposite C, so we have DCB, right? We know that the 4.3 is opposite B, the 4.3 is opposite C, so notice how these are in the same place. Then we know that angle D is the same as angle A, and we can find angle A by taking 180 minus 61 plus 53. And when I do that, I get 66, right? All of these add up to 180. So if this is 66, so is this. Okay. I enjoy these types of problems. They're sort of little puzzles. If you have questions, feel free to ask me. All of your Khan Academy problems are the same for all of your classmates as well, so feel free to work with them.